Now we're going to meet a humble robot. Okay? Does a simple job, but it's good at what it does. Table toddler. This is the robot. It's slightly different, pretty much Robbie, but it's just got 2 touch sensors on the front. Yeah, so the robot is designed, it's called a table toddler, and it's designed so that it'll be on a table, it'll be moving around in a forward direction, and it will never fall off. Basically, that's the idea. The 2 touch sensors will be pressed on the table, and as it's moving around, if it gets to the edge of the table, one of the touch sensors will be released, so it will back up, turn around, and go in another direction. It consists of 3 behaviours. One is toddler, which is just for moving forward. The second is back up left, and the third is back up right. Those coincide with the 2 touch sensors. So if the left touch sensor is off the table, so it will reverse and it will rotate in an anti-clockwise direction and then keep moving. And it's the same with the back up right. This is a demonstration of the robot actually working.
Is this for the real speed?
Yeah.
Wow. It needs a sensor at the back as well, doesn't it?
That was what you saw there was the problem with the actual hardware and the choice of the touch sensors, because it needs to be constantly pressed all the time by our design. Sometimes if it reversed back onto the table, they wouldn't be quite pressed, and so it would just keep rotating. And also sometimes it would get stuck off the edge of the table. We moved on from our table toddler to develop a table mapper, which basically uses the concept of the toddler, but it uses the concept of not being able to fall off an edge. So the robot will go to the edge of the table. Yeah, that's right. So what we want it to do is we wanted it to align with the edge of the table. So, as before, it would go off the edge of the table, then reverse, but then only move 1 degree, so that it was aligned with the table. And that was as far as we got with creating that code, but it would then start the table mapper, because it would know that it's aligned, and then it could keep going around the table. It would go to the one corner, it would stop, and then it would reverse, turn 90 degrees, and then it would move to the next corner here, and that distance it would measure, and then it would turn 90 degrees, go to the next corner, and then it would have that measurement as well, and then it would have both lengths, and then you could take the dimension of the table and you can do all sorts of things with that. How we planned it was to have a toddler as the primary behaviour, back up left, back up right, and driver, which controls it all. We used a differential pilot because it gave us more control over the movement and the rotation of the robot itself. Toddler had the lowest priority, and it was always asking for control, basically, because it was just the default. Back up left, as I've already described, take control. If the left-hand touch sensor is released, the action to reverse and to rotate and to suppress stops the motor. Problems we encountered was the sensors, and in certain situations it would hit the corner of the table, and if the left touch sensor was off, it would reverse, rotate, and then it would reverse and rotate, so it would be stuck in an infinite loop, which is never cool.